he said.
Hi, I'm Clinton. I'm from Obelisk Systems. I'm an electrical engineer. I'll start by introducing our team of people. Here we are, all staring directly into the sun, so we all look very squinty. We're a team of electrical engineers. So myself here, we all came through electrical engineering at University of Newcastle. My background is in simulation, so the picture behind me is calcium release in a heart cell that I did on a graphics card, which a lot of fun. Luke Hackworth, he's our probably our golden child, our Michael Jordan. He did his honours on prosthesis, so robot hands and stuff. So that hand right there connects to his arm and uses myoelectric signals to kind of move and actuate. His system was really, really good at the time. It's since been superseded. But this is Andreas. He's heaps into space. So he was into CubeSats, designed space hardware. This is Lewis Quill. He's power electronics. The horrible coil thing that you see here is the reason he nearly died a bunch of times, but his honours, which was a musical Tesla coil, which was quite impressive to see working. And the guy at the end is Levi. He's our in-house physicist. His honours project was building swarm robotics, so little robots that ran out and did stuff. So we started a company. That initially had kind of really big dreams of doing all kinds of fancy things, and we've sort of since come into education. So we started with space. So this piece of hardware here, we called this thing the Asimov, is a piece of hardware that was designed to be sent to the ISS. Passed all the approvals for getting put on board there, space-grade hardware. We worked a lot with a lot of other people in the space industry in Australia. The market's a little bit difficult to get into because there are a lot of very big costs in getting into space, like radiation hardening and all those kind of things. And the people that are playing in that game are universities who don't have to worry about making a profit, and people who are doing it for the fun of it and have a lot of money behind them. So we kind of hit a bit of a wall in that industry. But we did get this one job that sort of put us onto education, which I'll come back to in a minute. The other thing was Luke's brainchild, which after doing his honours thesis, he went for a while and worked on. It was kind of a device for helping stroke victims kind of rehabilitate. So it provided assistance as well as exercising to kind of restore strength. But he was kind of lured away from academic life into Obelisk Systems with the promise of building prosthetics. And so he had this device, which he was building further, kind of building it out to kind of be a more kind of low cost, something that could be sold very cheaply, easily customizable with 3D printing and all that kind of thing. As a result of kind of the space stuff, he got pulled off of the prosthetics and kind of fell a little bit behind, and so some other not-for-profits and stuff kind of jumped ahead of him a bit, so we kind of lost that market a little bit. So, and that's how we kind of came to education. Developing that space board for this other company, their kind of big selling point was sending code to space. So you write something, it goes up into space, you run your experiment. And so we had a lot of fun designing this hardware, kind of talking to teachers and kids. And so we thought we thought we'd have a look at that market. And so we found that there was kind of a gap in the market. So there were these really cool, exciting things that would bring people in, like there's F1 in schools, the ISS kind of program and stuff. And those kind of get kids excited, but they weren't really backed up with a lot of knowledge. And then there were other things like Mindstorm, which are pretty much just a toy. So we came up, being engineers, we saw a problem and kind of looked to find a solution. I say engineers a lot. My partner gets very angry with me. So the answer that we came up with was StarLAB, which is this little piece of hardware here. We wanted to build a sensor platform that you could give to kids so that they could learn about the world, learn about physics, learn about maths from code, and without having to have someone there that actually, like, a lot of the, like, Arduino is very affordable, but you need someone that knows how to deal with Arduino, with the wires, with the connections. This thing comes as a full package. It is, we took, not only that, but we took a lot of those skills that we wish we'd had when we kind of hit engineering at uni, and we kind of built a device that would teach those skills. To make this more kind of useful in a classroom, there's very little that needs to be installed. So there's an API library, and then you can just connect over the Wi-Fi network. The hardware's even been designed. Most people will tell you the nightmares of getting a Raspberry Pi connecting to the network at a school. I've actually managed to do that. I've had several teachers just want to steal my code for just that. So we developed a partnership early on after developing this board with a group called RDA Hunter. They have a program called the ME program. They work with big industry sector. I don't know if anyone around here knows AMP Control and Raytheon and BAE. Mostly defense companies. It's a little bit ominous when you start to look into it, but they provide industry skilling for schools. So they get money from these big companies because the companies need people that they can employ. Because in 10 years' time, when all these kids graduate, those jobs aren't going to be there. Those, like the metal turner and all of those things, they need coders. And so the ME program was about creating those skills through STEM education. So what we did is we built a package that allows you to teach physics, maths, and engineering through code. So you teach them Python or Scratch, and as they go through the Python lessons, they learn to code. We've kind of got 3 tiers at the moment of how you can use this device. So the first one is this, we call this the Sensors app. What it enables them to do is it's a data logger, so you basically just connect to it and you can live stream the data straight from... So once I'm finished here, you can come up and I'll actually show you how it all works and have a play around. But so you can record that data, plot it, analyze it later. You can do maths on it, like variance, and completely forgotten all the terminology for statistics and that kind of stuff. So I'm just going to pretend. So the next step is Scratch. So don't worry, these are my godchildren. This is actually the code they wrote. It's a little chaotic. They're a bit weird like me. So Scratch is a really easy program to use. We're currently working on lesson material for schools for that, but we just have the support for it. You can code our hardware. You can drive this robot. All of the functionality is there for Scratch, which is a lot of fun. Yeah, my nephew's had that thing driving around our office and running into people in about 10 minutes, which was a little bit chaotic of a morning, but it was a lot of fun. This is actually being, at the moment, considered for a bunch of primary schools in the Hunter Valley. So they're going to put a bunch of StarLabs in, give some kids a chance to play. The next step that we have, if my thing will work, is Python. So Python's currently the #1 coding language used in industry. It's used in all kinds of applications, even embedded applications. There's actually an embedded version of Python now, which is kind of crazy. But this the Python lessons that we have. So this is our kind of main product at the moment. There's an online learning platform, so kids log in and it takes them through from the beginning of variables through to actually programming this as an autonomous vehicle. And that course, combined with another document that we also provide for free for teachers, makes it so that we can map most of the new digital, actually pretty much all of the new digital literacies curriculum. So teachers can buy our package and they can, with no knowledge, with never having coded before, they can teach a class of students how to write Python as though they knew that from, like, it will teach them the things that they need to know, like from our engineering team, we're talking about this today, we have about 30 years of engineering experience between us. And like, so all the lessons from that experience are shoved into this course. So the teachers that are teaching your kids, like, at the moment, coding is being taught by TAS teachers who their history has been developing welding skills and woodworking skills, which so they are important skills, but they are a long way from coding. So they've just never been in this world. And this, I do not know what I just did. This is why I can't be trusted with computers. Not that I followed them very well anyway. So yeah, it gives teachers the resources that our kind of time has given us. So that, because if you have someone that doesn't have the support that this program gives them, then they're going to get stuck, and the teachers are going to resent the program, and then the kids will resent the program. It's the same problem that we've had with maths for a lot of years. Is people are like, I hate maths, and it's probably because their teacher hated maths. And if your teacher hates to code, then you're going to hate to code. And so this gives teachers... We had one teacher say, no, this is great because I just learn as the kids do, and we can all, like, I've just got to stay up to date with them, and we can kind of troubleshoot out each with, like, among ourselves, and it's a great deal of fun. We worked really closely with a school nearby to us called Maitland Grossman. They're a STEM action school, and they helped us to develop these resources. And we constantly get phone calls from schools saying, we're having this problem, and we kind of ship them emails. So in order to kind of hit that gimmick of getting kids really inspired about it, we have a Mars Rover challenge. Its major sponsor is the ME program and RDA Hunter. And so what this program, our course teaches them how to design an autonomous vehicle using this platform. And at the end of the year, kids will be able to compete in this competition either in person or over the internet. Because this is completely programmable over the TCP IP network, it means that kids in remote Australia, as long as they have an internet connection, can actually program and compete in the contest, which will be held in the Hunter Valley, but anyone can kind of log in and compete on the same hardware. So we'll have one set up that's a competition version, and people will log in and then try and meet certain goals. So at the moment, the kind of scoring criteria, at the moment, they're very draft at the moment, will be held in November, so we're leaving it very late, as we do. So they'll be marked on the efficiency of their code, on finding water sources. So the StarLAB has a humidity sensor, and that means that they can kind of detect different things on the course, so they'll be able to find those things. By customizing their rover, so they'll be able to submit kind of a document on what they've done. Different innovations they've come up with will also get them more points. And yeah, so we're kind of looking forward to that. Also dreading it because it's the first time we're going to run it this year, and first time you run anything, it's an absolute nightmare, and you always make terrible mistakes, which I've probably made a lot here because this is the first time I've done a presentation, so I'm very sorry. And so I think... so at the moment Python, but they will also be able to use Scratch as well. So basically whatever gets them to through the course. The different... I mean, we're going to award points for more elegant algorithms and those kind of things. And so it's more difficult to implement a really nice algorithm in Scratch. Still, it's not impossible. You can do some very nice things in Scratch. But yeah, it's hopefully going to be more about the engineering, about the thought processes that go into it, rather than the actual code. Like the program has been designed to teach STEM, not just Python. But kind of you learn Python. Well, we learn Python, and it's integrated. It's kind of the idea of the whole program has been to bring all of those things into one course. We teach, so there's a barometer on there, so we teach in one of the lessons how you can use that barometer reading to find the altitude and like the maths, and Levi made some very linear approximation to what the altitude would be at sea level. I just shot myself in the eye, which was a lot of... So you can use... So it teaches the maths, the physics, and the coding that you will hopefully need to do any of these things, and just to kind of teach those thinking skills, the computational thinking, which is very important these days. I think I kind of ran through that maybe a little bit too quickly, so probably ask me lots of questions because I've missed a lot of things.
Run teacher sessions?
Yes. Not well. I'm developing those at the moment. It's kind of my baby at the moment, is running professional development for teachers. Currently working on getting that board endorsed status, so that we can get teachers, because our program's very easy to use. But no matter how easy it is to use, teachers are still absolutely terrified of coding. So they tend to want you to hold their hand. I've run a few like intro sessions at our office, and they've come in, and like by the end of the session, the teachers love it. But at first, they're a little bit hesitant. But yeah, by the end of the first session, they're like, "Oh my God, this is a data logger!" Like, I have a whole lab full of these that are awful to use. This would be so much nicer. But yeah, any other?
Could you go through like the range of sensors?
Yes, I can. If I go, this may work. Here we go. So this one here is a temperature sensor. There's actually 4 of them on it in different places. You can kind of use them to sort of estimate the air temperature. Because they're mounted on the surface of the board, they do tend to couple quite strongly to the board. So it's another physics lesson in one of the lessons. So the mistake was made, and then we made it into a lesson in the... I mean, it was deliberately designed that way to teach a valuable life lesson. There is an IMU here. So that's accelerometer, gyroscope, and magnometer. So in 3 axes as well. So you can kind of work out your orientation, the acceleration, so you can tell when you bump into things or anything like that. These ones, a lot of you will probably recognize as ultrasonic. They attach with the rover, so this part comes apart, and so a lot of different expansions are planned. We're planning a chemistry one soon because by popular demand. We have an engineer like you who just spends all his spare time designing new things. He got Scratch working in a weekend. That was pretty amazing. Yeah, so the next one is that one, which is infrared and ultraviolet light. So you can kind of see what those light conditions are. There's also an ambient light sensor, which can get color balance as well. One of the workshops that we run has a course that we've got set up with different colored lights. And so you can write a Scratch program that the code drives through and then turns, and then like based on what color the lights are. The challenge of the exercise, we kind of give them the code, but the challenge is they have to kind of work out how long it needs to turn for, which depending on the length of it. So if we run that session for 20 minutes, mostly they don't get it, so they're very disappointed. But because it's amazing how quickly the errors build up when you're kind of timing things like that. And a barometer, which enables, which gives us the humidity and air pressure. So that's what we're hoping to leverage to use the finding water on the Mars terrain. And of course the camera. There's a programmable RGB LED, which has a kind of, you can write this really simple program that takes the color balance and then displays it in the RGB LED, so that the light matches whatever the color balance in the room is, which is kind of a pointless program, but kind of cool, I guess. There's 4 LEDs here that are also programmable, and these buttons and joystick here can also be programmed using Scratch or Python. Trying to think what else there is. There's also a buzzer that you can't see, which is always fun whenever we're running events, because of the way these things work, if everyone here had a laptop, you could all be connected to this, taking data at the same time, and also programming it at the same time, which has resulted in several events where it's never the kids, it's always one of the teachers. And what they do is they just wind the buzzer all the way, like just a for loop that just keeps it going, increasing frequency until it's just that horrible ear-bending noise. So, yeah, always the teachers. I don't know why. But yeah, I think, yeah, it also, connects to the Wi-Fi network. Did I mention the camera? Yeah, the camera, which can take... You can program it to take still photos or video. So you could use this as a time-lapse camera for different things. We're talking to one teacher about setting up a little kind of different environments. So like you could put it in a black box with the StarLAB and a plant, and then have a bunch of LED lights of different like frequencies in there. So like an ultraviolet light or something, and you could see how the plant grew under that particular lighting condition, and like record what the lighting conditions were and also the pictures that it takes. Which could be interesting with depending on the color of the light, might make the pictures a little bit less interesting. Yes.
So what sort of work are you doing on the ISS? Are you all trying to navigate the ISS, or?
We designed a sensor platform to actually send to the ISS for another company. It went through all of the approval processes. We're not 100% sure if ours was or was not the one that was actually sent up. There was some issues around that. There were problems with the mission from the beginning, and we kind of advised of that, and so they weren't happy with us advising with that. So I can't really go into much more detail than that. We kind of... The problem with space, and particularly something like the ISS, if you run an experiment on the ISS, you're pretty much running it in a lab. Like it's a lab with some unique gravity, slightly less interesting gravity, really. So it just sits there doing nothing all the time. And so you tend to get a lot of nothing happening. there are some cool things you could do if you were on the outside, but then your hardware tends to last a little bit less long because of radiation. But no, yeah, the ISS thing, yeah, that's about all I can say. Sorry. Yeah, any other?
What's you do for battery?
So in this one, the Rover has a LiPo, so it's 7.5 volts. It powers the motors, and then we have like a step-down power control that powers the Raspberry Pi. This powers off USB, so any phone micro USB battery pack will work. When you buy one, we give you one, and it usually lasts. I think the one that we have is fairly small, but it lasts about 2 or 3 hours. The Rover battery, depending on how much you're driving around, lasts about the same. If you're driving it a lot, it'll flatten quickly. This one, we actually had a previous version, which kind of an interesting story. We decided that we'd order them from a supplier in China because we thought if we don't design it, because we're all electrical engineers, we thought if we don't design it, it'll work and we won't have to worry about that. Yeah. You know where the story's going. So we got the first 3 and they all worked fine. They were great. The Hall effect sensors were good, everything was fine. And then the production came and I think we could use about 5% of them or something like that. And so we're like, well, this is not good. So Luke, who was the guy that did the robotic hand, he actually designed this whole thing in about 2 weeks and started 3D printing it. And this one has slightly more powerful motors though. The original one struggled on inclines of about this. This one will just power up. Also, it has some safety features built in now so that it doesn't chomp anyone's fingers either. The other ones had no possibility of doing that. These ones have power limiting in them so that they don't do that. Yeah, it's probably not as interesting as I claimed, but it was a lot of fun. Sorry, I keep talking. Any other questions? Yeah, I can indeed. I remember. No, that's not even necessary. So, as long as my IP address is still the same. So, this program here was written by one of our engineers. It's a really simple program. Well, not quite that simple. It uses Pygame, but it just takes keyboard input and pushes it out to StarLAB. So these are kind of, we have an API that kind of sort of control the elements by selecting different parts. So this, while it's running, it kind of outputs the voltages and stuff. But if I run this program, and hopefully my laptop's not being painful today. What's happening there?
Logging that I see on the screen.
So that is currently at an insane speed, logging the battery voltage, and where was the other one? Battery and processor voltage. So the two power, like the motorboard on top. The motorboard on top also has the functionality to measure the voltage at the time and the current through the motors. So you can monitor how much power you're using, which, because we're doing that whole Mars rover thing, knowing how much power you're using is something that was very useful, because when you're on Mars, you don't have that much power available to you. So that's kind of what that was. There was a reason we had that, and I'm trying to remember what it was. I think it was when we were testing whether the batteries would go too low. So it was, Yeah, no. There's a cutoff, so the thing will shut down if the battery gets too low because it's a LiPo, and you don't want LiPo batteries getting too flat. So the thing will turn off before the batteries go problematic, which works because one of the schools that we have left it running overnight, so there were no problems with it. But yeah, if anyone wants to come have a play, or if there's any more questions, I'm happy for both. Yeah, thank you very much.
So, yeah, thanks, Clinton. That was awesome, and the StarLAB system is extremely impressive. So, thank you so much for coming all the way from Newcastle to present that to us.
It was worth it.
Definitely, yeah, very, very much appreciated. So, I think that concludes the presentation part of the evening. So, I know Phil has also bought some hardware, and please come and have a play with Clinton's StarLAB system, and I think you could have a look at the Coda Dojo stuff as well. And I think we've got about 15 minutes before we have to kind of shuffle out. So, and thanks everybody for coming tonight. It's been really fantastic. So.